So example number 3, differentiation of parametric equations. You've been told, determine the equation of a tangent drawn to the ellipse. X is equals to 3 cos theta, y is equals to 2 sin theta at theta, pi over 6 radians, isn't it? So you know very well, for you to determine the equation of a line. Remember, tangent is a line, isn't it? For you to get the equation of a line, you must get the known gradient, you must have the known gradient and one known point, isn't it? Are you together? You must have the known gradient and one known. So you know very well the known point xy, isn't it? We must determine this point xy. So you are asking yourself, what is the value of x when theta is pi over 6, isn't it? What is the value of x when theta is pi over 6? And you know pi over 6, if you change it to degrees, that is 180 divided by 6, you get 30 degrees, isn't it? Are you doing there? So what is x? X is 3 cos theta. So at a point when theta is pi over 6, you get x to be what? 3 cos 30 degrees or cos pi over 6 in pi radians, isn't it? You get it to be, you get the value of x to be 2.5. So that is 2.6, isn't it? So x is 2.6. Then you go again. What is the y? Remember, y is 2 sin theta, isn't it? So at a point when theta is pi over 6 or 30 degrees, what is the value of y? It is 2 sin 30 degrees. You get 1. Are you seeing that? So it means the known point xy is which point? X is 2.6, y is 1. Are you seeing that? So we already have one known point. So what we need is the gradient, isn't it? So how do we get the gradient of a tangent? We say the gradient of a tangent is the derivative of the curve, isn't it? Can you recall that from coordinate geometry? The gradient of a tangent is the derivative of the curve. And what is the derivative? The derivative is dy over dx, isn't it? Meaning if we are able to get the derivative of the curve at that point, then that is the gradient of the tangent, isn't it? Meaning the gradient of the tangent m is the derivative of the curve at the point when theta is pi over 6, isn't it? Are we together? So what is dy over dx? So it means your y is a function of theta, you are differentiating y with respect to theta, x is a function of theta, you are differentiating x with respect to theta, isn't it? So if you have dy over dx, it's like you are dividing both numerator and denominator by the theta, isn't it? Are we together? So dy over dx is the same as you divide dy by the theta over dx divided by the theta, because you see here very well y is a function of theta. Meaning you can get dy over the theta, isn't it? You see that? You can get dy over. So what is dy over the theta? Meaning you differentiate y with respect to theta. So if you differentiate this, what do you get? Y with respect to theta, you get 2 cos theta. If you differentiate sin theta, you get cos theta. This is constant, isn't it? If you differentiate theta, you get 1. So we are done there. Over, what is dx over the theta? You are differentiating x with respect to theta. If you differentiate cos, you get negative sign, isn't it? So 3 cos theta, if you differentiate, you get negative 3 sin theta. So you see, this is, you found the derivative dy over dx, isn't it? Then having done that, we want it at what point? When theta is pi over 6, isn't it? Meaning where there is theta, you put pi over 6 or 30 degrees, isn't it? So when theta is 30 degrees, what do we have here? Negative 2 cos 30 degrees over negative 3 sin 30 degrees. If you are working with the calculator in a D, if you are working with the R, you put it in pi radians. So 2 cos 30 over negative 3 sin 30, we have what do you have? You have? My friend, just putting 2 cos 30 divided by negative 3 sin is a big deal. Negative 1.15. So you have negative 1.15. So it means the derivative of the curve at the point pi over 6 is the gradient of the tangent, because that is the point where the tangent touches the curve. They are sharing that same point. Meaning the derivative of the curve at that point is the gradient of the tangent. Are we together? So the gradient of the tangent, you found the gradient of the tangent to be what? To be negative 1.56, and you found one known point to be 2.6 and see, you equate the non-gradient and the non-gradient. You know very well that gradient is changing y over changing, isn't it? So that implies what? The gradient you found to be negative 1.15 to be equals to changing y is y minus the y value, isn't it? Remember the known point is x is 2.6, y is 1, isn't it? See, changing y is y minus 1. Are we together? Then changing x is x minus the x value, x minus 2.6. So simplify, cross multiply, take this one this side, you get rid of that denominator, you get y minus 1 is equals to negative 1.15 into x minus 2.6, isn't it? Are you together? So if you take negative 1 the other side of the equation, what do you get? You get y is equals to negative 1.15 times x, you get negative 1.15x, isn't it? Go on, negative 1.15 times negative 2.5.6, negative 1.15 times negative 2.6, you have? We have 2.99, isn't it? Yeah. Then you see negative 1 going on the other side, it becomes positive, isn't it? So it is plus 1. You get 3 point. So you simplify it, isn't it? So it is in the form y is equals to mx plus c, where m here is the gradient. Are we together? So the key point there, you must always know the key point there. The key point, the derivative of a curve at the point is the gradient of the tangent at that given point, isn't it? That is the key point. Meaning if you are trying to find the equation of a normal, then it means the derivative will only give you the gradient of a tangent. So you use the normal is perpendicular to the tangent. So gradient of a tangent times gradient of a normal is equal to negative 1, isn't it? Perpendicular lines, isn't it? So for you to get equation of a normal, you must get the gradient of the tangent first, because that is what is coming from the derivative of the curve, isn't it? Are you getting that? Then you use the relationship between perpendicular lines, between gradients of perpendicular lines, isn't it? The product of gradients of perpendicular lines is equal to negative 1. Then with that you will be able to determine the gradient of a normal, isn't it? Good.